So I get this video from my brother the other day, and this is off his security camera he's got set up in the backyard. And if we go ahead and play this, you'll see that he caught a fox in the middle of the night there, sniffing around the chicken coop. And he wanted to know if I could build something for him to scare this fox off. So here's what I whipped up here, and it's a perfect project for the trigBoard. And if we walk in front of this box here, we set off the motion sensor, and yeah, I think that's going to do the trick. So this is kind of a fun project, so let me show you how to build all of this. So over on the trigBoard docs here, I created a new project for this, the motion activated mp3 security system. And here we have the diagram showing all of the parts used for this project. And of course, this is based on the trigBoard. And we're using a high quality Panasonic PIR motion sensor. So this whole thing in standby as it sits right here is pulling like 2 microamps. That's it from the battery. So this is going to get really good battery life. And again, because it's based on the trigBoard, we have the ability to send push notifications out as well. So in addition to playing the dog barking, we can also send out, a push notification to the phone using pushover. If you go over to supported services here, push safer, push over. If this then that, you can send out emails, Telegram, UDP, TCP. It goes on and on and on, all the different things you can do here, or even like tie it into your home assistant with MQTT. So anyway, getting back to the project here. So the first thing to talk about is how to play the audio, and for this I'm using one of these little MP3 player boards. So if we go to that link here, these are these super cheap little player boards. They've got an SD card slot on one side. You load that up with all of your MP3s, and then over a UART connection to the ESP32, you can, play whichever file on the card you want. So then I just used a little 3.5 millimeter audio jumper cable there to then go and feed the audio amplifier, which is just a super cheap Class D amplifier. And this one you can feed off of 12 volts. See, I really wanted to get some decent volume out of this. So I went with a 12 volt one. Now I don't have 12 volts available on the trigBoard, but the 3.3 volt rail is switched on when the trigBoard wakes up. So when it detects the motion, the 3.3 volt rail turns on, and that will feed over to a booster board here. So let's go to that. So that 3.3 volts feeds the V in here to the booster, and then before I connected anything to the output, I set the output voltage here with this little trim pot, because who knows what the voltage is set, by the factory. So I don't want to blow anything up, so I connected a meter up to the output here, and then adjusted that to be 12 volts, and then made my connections over to the audio amplifier. And then the last major piece here is the PIR motion sensor. So this is a super high quality, obviously very expensive PIR, but these are awesome. So let's go to the datasheet for a second here. So look at the datasheet here for a second. 1 microamp is all this thing pulls. So this is the one I went with here, the pearl white, long distance. So that's 12 meters or about 40 feet of detection distance. Pretty incredible. So this really is a perfect match for the trigBoard. Here you can see we're powering it at 4 volts. The average current is less than 2 microamps. That's crazy. For the entire system, it's just sitting there, is only pulling 2 microamps, and it can still wake from the motion input there, as you can see. And then it goes back to sleep. Now we've got some pretty high peak currents when this does wake up, so I recommend using a pretty beefy battery. Here in this example, I'm using a 2500 milliamp hour battery, but I think I'm actually going to switch that out for an 18650. And the only other component here is the speaker, and this is just something I had laying around in my junk. So it's just an 8 ohm speaker I probably pulled out of something, who knows what. But that works pretty good. And if we scroll down here, here's the note or the warning about setting the booster here before you connect it to the audio amplifier. And these are the connections. So when you look at the back of the PIR sensor, this is the pin out there. And of course you want to double check that with the datasheet just to make sure you've got everything hooked up. So that connects straight over to the sensor input on the trigBoard, and then the ground we actually have to go and solder over to the trigBoard. There's the 3.3 volt rail that is turned on when the trigBoard wakes. So that applies power to the MP3 player board as well as the booster. Then the output there from the booster goes over to the audio amplifier. And I actually hardwired this to the booster or to the amplifier board. And there you can see those connections on the backside of the amplifier. Now this might be kind of hard to see, so you can click download diagram and that will blow this up. And we're using GPIO 33 and 32 for the UART connection over to the MP3 player board. We're using a software serial library for that, so keep that in mind when we go over to the code. Alright, so that covers all of the parts and connections. Now we can jump into the code. Now this is a great project to demonstrate how you can modify the base firmware for any custom project you might have. But before you do this, make sure that you can at least compile and upload the base firmware. So if we go over to the firmware updates and programming section here, this kind of shows you how you can upload the code, the settings I use in the Arduino IDE for this. And this is important to do because we are going to modify that base firmware. So if you can at least upload that, then you can make modifications to it. So anyway, let's go back here to the project page and go to source code. And this will take you over to the GitHub page just for this project. So then we can download that code out and bring it into the Arduino IDE here. Now, one of the cool things I added to this was my brother was like, I don't want this thing like going off all day long, driving the kids nuts. So he only wants it active after about 10 o'clock and before 8 a.m. Now, we could have used the light sensor for this, but he still wanted it active even, you know, the early hours of the morning. So we're going to use the RTC for this. And there's a new feature actually in the trigBoard you may not know about, but the RTC clock has this interval wake, you know, that wakes every, 4 hours or 2 hours, whatever you want, to check if like a door is left open. Well, it also has a clock wake, which actually is like wall clock time. Let me show you how this works. We're going to go ahead and click or press the wake button, and we'll hold that down until the LED is flashing. And we're going to go over to the configurator page here. We're going to connect to the trigBoard over Bluetooth. And if you scroll down here, you'll see the new feature here, Clock Enable. So this is actually keeping track of the time of day, which we can actually synchronize off an NTP server. But before we do that, we need to connect to a Wi-Fi network. So let's go ahead. We've got the credentials in there. Save and connect. Cool. Now we're connected. And we'll go ahead down here and you'll see set time with NTP server. Set the time. And there it is, 1718, which is, 518. So we're good to go on that. Now in the code, we can use that. And you see here in the code, if you scroll down when it actually wakes up, we would normally only check to see if we're supposed to wake up with push logic. But now we can check to see also if our current hour is between 22 and 8. So about 10 o'clock at night to 8 o'clock in the morning, we can wake up and enable the dog barking. And I've added a couple things here to do this. So like we make a call to RTC get time, and I've added a variable in there to set the current hours to this variable here, current hour, so that we can actually get and use that here in the code as part of our wake logic. And then we won't, we don't want to actually like make the dog bark if there's a timer wake or if you press the button. So we make sure that we check to make sure that neither of those are active. And then we go through and actually play the file. Now, a couple other new things here in the code. So there's a tab here, mp3. So this is all added in as part of the mp3 player board. It's just a copy and paste job. If you go over here, I've got a reference from where I got all of this from. So it's pretty much just, I think, a copy and paste of that. I've only had to make a few modifications to this code just because it's kind of a long story, but this code was originally written for the YX5300 chip, which is not what they use anymore in these little boards. Even here you can see that IC is not the same IC as the board I've got. You can see it's totally different package and everything. So it's not fully supported by this code, but I've made some tweaks to it so that at least it plays files. I'm not going to get into this code too much because I've already made videos on this MP3 player board. In fact, it was part of my ultimate home security system, the cellular battery backed system here. And if you go to monitor setup, I've used that same exact board here to play files for, like, when the door opens, it'll say the door has opened or the mailbox is open, those kinds of things. So I've got a ton of documentation and tutorials on this already. And by the way, this is how you set up the files on the SD card for that board. They all have to be in this very specific kind of format. So you have to create a folder, 01, and then within that folder, you have all of your files. So, 001, 002, and so on. So you can give them file names if you want or not. I just have mine as 001 on this, and I only have that one file. So, and then when you go back to the code here, the way it works, track to play is 1. So this will play 001 on the SD card. And I know I'm kind of rushing through this a little bit here, but I just want to quickly show you what changes are from the base firmware to this. So I've added this in as well on the includes.h file. So here you see, those software serial connections over to the MP3 player board, the 3332, and how that's set up. So you will need to also install the software serial library to get this to work, besides, the other libraries that are needed by the base firmware, which are these here. And I know I'm all over the place here, but what's cool about this specific PIR motion sensor is that it works directly with the trigBoard. So you see those connections go straight in, and when we go over to the configurator, you see that we only have to wake on contact close. So that's when the motion is detected. So contact close, it wakes up, and then we can actually, like I said, because it is a trigBoard, we can send out a push notification if we want to. Now, in this case, my brother doesn't really have great Wi-Fi way deep in the backyard there, so we're not going to send any push notifications out. It's going to be purely just the dog barking when it wakes. So that's pretty much all there is to it. So that push logic will go true when that motion is detected, and then, of course, the current hour must be between 22 and 8. And then, of course, also we don't want it to bark if the button is pressed or the timer woke it up. And then we go and play the file, and then it would do its normal trigBoard stuff down here to send out push notifications. So just kind of a fun project there, and a demonstration as to how you can modify that base firmware and use the trigBoard in other kinds of projects. And the last thing here is I've got this all buttoned up in a cheap dollar store Tupperware container, so we're going to see how this whole thing works. And I might make a follow-up video if we actually can show the thing scaring a fox off. So anyway, hopefully you found that interesting. Thanks for watching.